All right, we're all back. And on my screen, what we've done here is that we've created a sales manager class that inherits your employee. That we have that right up here. It takes base salary and estimated annual sales as arguments as we initialize. Yep, we've got that here. We're storing that as instance variables. We've created the added readers for them. And we've created a bonus method on sales manager that returns 10% of estimated sales. So we've created a bonus method. And that's going to give us the estimated annual sales. It's going to be 10%, so we're multiplying it by 0.1. And over here in the runner, what I've done here is create a sales manager. And now the arguments are the base salary is going to be 15 and the estimated annual sales is going to be 100. And we see here that total compensation will still work because when we're referring to bonus is not going to, there is no bonus added instance variable. Bonus is just hitting this method here and doing the math in here and calculating. We get, as you can see, we get the 25. Any questions about basic inheritance so far? Karen?
Sorry, I'm just asking a question so I have some time to process this. So in our runner file, we're requiring CEO and sales manager.
Mm-hmm.
Okay, the end.
Because we're both instantiating the CEO here. If I were to take this line out, I could just take out that as well. But I wanted to leave in the first one, so that's why I left it there.
Okay, thank you.
Mm-hmm. Anything else from anyone? Cool. All right. If that's nothing else, let's take a Pomodoro break. Let's see you back at 9:41. It's a 5-minute break. We'll be back at 9:41. All right. So as we are back, the next thing we're going to talk about is calling a parents method, and we use that with the super keyword. And so let's make some changes. I'm going to close my runner here real quick. And all right. So let's say for, in this case, we want every single employee we want to have a name and ID, right? And so what we're going to do is that we're going to make some modifications to our employee. We're going to do def initialize name ID. And this is going to be at name. Cool. And then we're going to excuse me. Cool. So the problem is like, well, now we have this and we want to use it. We want to update things so that our CEO can take the name and ID as well. So what we're going to do is that we're going to change our CEO object to also take in the name and ID. And so like the thing here is like, well, we have base salary and bonus and we need to set it to name and ID. And like the idea is that we don't want to do at name equals name here and at name equals ID here because we already have that in the super class. So what in the employee class. So what we can do is that we can call super and we can send like the things in this way. We do that like super name comma ID. And so what happens here is that when we are instantiating, we're creating a new CEO object. We are sending it in these 4 attributes. 2 of the attributes, base salary and bonus, gets set in the CEO class. And then like with the whatever we have left, the things that are common to all employees, this gets sent over to the employee object and then set there. So I'm going to change my runner file. Let's get rid of the sales manager. We're not dealing with that now. And let's modify our alley object. The name is going to be alley, and the ID is going to be 1. Excuse me. because CO employee 1 makes sense. Save that. And we can see here 35, that checks out. And that still works. So again, what we're doing here on this line 10 is that the call super calls the employee class as initialize. Super essentially means, hey, I want you to go to parent and call that method. And there are actually three forms of the keyword super. And I'll put that here. Number 1, super argument 1, argument 2. What this does is it calls the superclass method with these arguments specifically. And when I say call the superclass method, what I mean by that is that because super is an initialize, it will then look for the initialize method in your employee. That's how, the name's got to match, right? It doesn't just like kind of like, the idea is like, well, how does it know which method to call like the one it's in? It's looking for the one with the same name. The second one is that super by itself, like this, calls superclass method with all arguments. So essentially, if we go back to our CEO example, it would send all 4 through to the superclass method. And finally, super calls with no arguments. Like we're specifically saying, hey, pass nothing. This is probably the only instance of where we'd call method with empty parens at the end. As you may notice, like we generally do not use empty parens, but like this here, we're trying to say explicitly, hey, I want you to call the superclass method, but I want you to do nothing. Questions about using super? Karen?
So currently we're using the super with the argument 1 and argument 2 in our CEO class, right?
Yes, because you're sending in the name and the ID. You don't really care about the base salary and bonus because you're using that here.
So if we in our runner file puts Allie.name, we should just get her name returned.
Yep. I can demonstrate that. The 35 in the alley.
Cool, thank you.
Doug?
If our superclass has an initialize that takes arguments, do we have to pass arguments in like the first time, or like because we're inheriting from employee, do we have to pass in arguments, or only if you want to use them later?
Only if you want to use them later. Like we could easily just, so the idea is like, let's say we take this away, right? This will still work, except for Allie.name won't work because Allie's never getting called. So when we don't call, when we have something like this set up and we're not using super, this doesn't get run because we're only running the initialize here.
So
we're going to see that there is an order
initialize.
of press. Yeah. Like super, what super does is like, hey, go to my parent class and run the same method name. Without this super, this initialize takes precedence and will only run here. We're going to see a little more about that in a second. Cool. Other questions about the supering? Cool. Ben?
I just had one quick question about whether the super will run specifically the initialize or whether it'll run the method that it's currently.
It runs the method that it's in.
Right. So
I
think
the same name. Yep.
I don't want to confuse Doug about having the super specifically run the initialize function. That was the only thing I was worried about.
All right. So the next thing, let me uncomment. Let me re-uncomment this out here. And I'm just going to run everything again, make sure I didn't break anything. Cool. That still works. I'm just going to take out the printing out the name here. We don't need that right now. Cool. And so the big picture here, I mean, like another thing that we can do is that we can also override methods from our parent class by redefining in our child class. And the idea is that like we do this when there are exceptions to the rule. The example I like to use is like, let's say we have a dog superclass and we're creating a subclass for each breed. And the idea is like, well, some breeds shed, some breeds don't shed. Or some breeds have hair, I guess. Yeah, there are dog breeds that don't have hair, which is a weird thing. So we can set kind of like these exceptions. So let's do this. I guess the example in the lesson plan is that a mammal class might have a method called lays eggs that returns false. But if we were to make a platypus class, that would have a lays egg method that returns true. Yeah, I guess platypuses do lay eggs and they are mammals. So that makes sense, kind of. So let's kind of do this here. Let us create an intern class. We're going to require employee because that is what we're inheriting from. And the initialize, it's going to take an hourly rate. And of course, a name and ID. And so like interns are an exception to the rule, right? Like who ever heard of an intern getting a bonus? Like no, that doesn't happen. So what we're going to do here is that we're going to make a total compensation. And that's going to be hourly rate times 2,000, say the intern works for 2,000 hours. And so what's happening here is that when we call total compensation on this intern object, this method here is going to be run instead of hitting the total compensation method in the employee. It's this idea that when we are trying to find things in our class, right? The idea is that like when we run the total compensation object, total compensation method on an object, it's going to look inside that class. It's going to look at the intern class first. And when it can't find it, it'll go upwards this chain. Like for example, CEO, if we run like we have here in our runner, puts Ali.total compensation, it's going to look, Ali is of the class CEO. All right, so do we have a total compensation method in the CEO class? We don't. So what do? We go to the next thing up. We're inheriting from employee. So we are going to look in the employee class like, hey, is there a total compensation method in here? Yes, there is. That's the one we use. Here, we instantiate an intern. We're going to run a total the total compensation method on the intern object. Cool. All right. So is there a total compensation method in intern? Yes, we use that. It's this idea, like I like to describe it as like, we use the first thing we find. Like there's a saying, like it's always in the last place you look. I'm like, yeah, it's gonna be the last place to look, because when you lose your keys and you find your keys, like, are you gonna keep looking for your keys after you found your keys? Like that? No, that's ridiculous. We have found the total compensation method. Like, cool. We're going to use this one. We're not going to go up and look for other total compensation methods that exist up the chain. That's just kind of like this big waste of time. Questions about what we've done here so far? Cool. Tommy?
Yeah. Would you put it out there that it makes more sense to have a chain of parents or to just do the override?
Oh, that's a good question. I think that there are bigger structural questions about like having this chain of parents. I think that using inheritance in this way is a way to organize your code and structure things in this very specific kind of way. And so usually when writing code, I would not go ahead and use inheritance as a tool to like kind of start things to start with. Inheritance for me, and I think that in general, should be this tool that you use to refactor. Like, like this idea is like, okay, so let's say I'm making this this animal shelter app and I have a dog superclass and I have all these breeds. And it's like, well, you know, like what if I only have like 2 breeds? Like that doesn't feel like I'm wasting all that much time if I have this dog breed kind of relationship. And so I would rather write like, okay, I have a Corgi class, now I have a German Shepherd class, I have a Golden Retriever class. And like after like 5, 10 or so, I'm like, okay, I should probably refactor this out to use inheritance because it's easier to go from multiple classes to refactor out to inheritance than the opposite direction. So I think it's a big question of like how complicated, what am I gonna have to do? I would, in general, I would never use inheritance as kind of like my first tool structurally starting things out. Does that answer your question?
Yeah.
Cool.
Thank you.
Yep. Regina?
So, intern is inheriting from employee.
Yep.
I don't think I understand why they are both allowed to have a method with the same name.
Yeah. So what we're doing here is that this is overriding it. We're
Okay.
saying like, hey, for an intern, this is what the total compensation is going to be because interns don't get bonuses.
Okay. Okay. So yeah, it's just overriding it. Okay. That makes sense.
Yeah,
Thank
that's
you.
why we're doing the same name because we want to say like, hey, I want to use this total compensation, not this one.
Okay. Thank you.
Mm-hmm. All right. So we can also combine super and overriding. So let's go back to employee, and we decide in this fictional company of ours, we want every employees to get sick days, right? So we do def benefits. Did I spell that right? Yeah. Did that. And so what we can do here is that like the CEO is going to get sick leave. But another benefit we want to give the CEO is health insurance, right? Like health insurance is pretty cool. So what we can do here is we do def benefits and we do super dot push So now, if we were to print out Allie's benefits, it would be sick leave and health insurance. For our intern, it would just be the sick leave. For our sales manager, just the sick leave. Although, sales manager could probably have health insurance too. Right. So what's happening here is that we're calling super. Let's kind of break this down. And what super does is it calls the same method name in the super class, which is benefits. And the return value of that is this array with the symbol sick leave in it. So we have that sick leave in it, and then we're going to push or add in the health insurance. So now the return value of benefits is this 2-item array with sick leave and health insurance. And that is one way that we can do that. Ben?
So I'm wondering, in a runner file or something, if you called benefits multiple times, would it rewrite it just so it's like benefits and then pushes sick leave, and then when you call it again, it's only because you're not actually pushing it in the employee class. So would it?
No, it doesn't.
So
It
would
doesn't.
it would have
It
a
does
bunch of
not
health
maintain.
insurance?
No.
Oh, okay, yeah. So
Absolutely.
it would just be benefits or sick leave and health insurance every time you called it. Okay.
Karen?
So right now benefits is an array. Can we see you do that as a hash or no?
Yes. It depends on like what you want to do to it. Because it's like you just add things to the hash as you would any other collection. Like it doesn't matter that it is a hash array. You could do whatever you want. Like we could have this be, let's say, we could do something like sick leave, and then this we could probably change to super plus space insurance, like that. You just concatenate onto a string. You can certainly do with hashes, like it's just as any other object.
Okay. All right, thanks.
Trevor?
So in the case of like we were talking about CEO and sales manager would probably both have health insurance.
Mhm.
Would it be, if you were building out that kind of thing with the inheritance, would it be smarter to do something, or would it be better for using inheritance to, in the benefits in employee, to put it as sick leave and health insurance, and then you'd only have to modify the intern class to take off
Probably,
sick
yeah.
health insurance? Okay. I was trying to make sure if that's the
Yeah,
right way
it
to kind of
depends
think
on
about that.
how many are in each and how many exceptions you plan on having. But the problem is that like no one really knows how many exceptions you're going to have until like you deal with it, right? Like,
Yeah.
Like right now, it's like, oh, we're just going to do this, and then if we have more kinds of employees, it's time to think like, well, health insurance would probably go here. So to kind of like talk about that scenario like you're describing, what I would probably think about doing is that I would do sick leave, health insurance, and over an intern, I would probably have death benefits, just be sick leave like that, because it is more the exception in this case. So you'd have to figure, like which way you go depends directly on like the number, right?
Okay.
Yeah,
Cool.
and you'll figure that out as you go through. Cool. Other questions at this point? I'm just going to take this away. You have until I reset things. Questions? CEO, that looks good. Employee, that looks good. Cool. All right. So the lesson plan has you create a override a method so that when you call total compensation on CEO, it adds $1 to the base salary before returning the total compensation. And that would be something like, I would just do F total compensation plus 1. Yeah, something like that. Or like base, it would I guess we are like going exactly by what it says. We'd add $1 to the base salary and then return the total compensation. Cool. All right. Cool. So going back to what Tommy was talking about, like how do we kind of like decide to use inheritance? And the thing is that like I think that when we kind of do this thing, we learn the inheritance. Like as soon as you have like a couple of subclasses, you there's this temptation to just start and go and like, oh, let's just do inheritance right away. We'll have this animal thing, and we're gonna have the super class. We're gonna have all these child classes. That works great. But the problem is like when you just have like a couple of child classes, there's a lot of overhead, and it's not really worth doing. And the idea is that it is cheaper, it is easier and more efficient to take a bunch of child classes to convert like child classes to using that parent-child relationship rather than to take a parent-child and then like split things out. It is easier to move things, to pull functionality up and consolidate than to like kind of move things and pull things downwards. Another important note is that while subclasses can rely on functionality from the parent class, a parent class should not depend on the subclass. The idea is that we want to like put things in appropriate levels. Like the idea is that the dependency should go in one direction, not the other. Cool. Other questions about inheritance so far? Anything we want to talk about? Any kind of questions? I'll take a sip from my water bottle so it's not awkward as you come up with questions. Joseph.
Yeah, I was wondering, do you like to start off by making super classes and then creating subclasses, or is it a refactor thing that you do?
In general, like you want to refactor using inheritance because it's like, you know, creating these extra files, like that's work, right?
Mm-hmm.
And I think the idea is that we want to avoid painting ourselves into a corner. Like what if you realize, like you start doing it and like, oh, for example, I guess an example is like, hey, we're starting a dog sanctuary, right? And like, it's great. We're going to have classes for all the breeds, and you go and you build out like 50 breeds with this parent-child subclass structure. Or even you can get even more fancy. You could have like families of dogs. Like you could have like a dog, a mammal superclass, and then below that you have like a dog one, and then a dog one you have like shepherds under one. You know, you have this whole chain, and then all of a sudden like the powers that be like, yeah, so we're actually just going to be a corgi rescue, and then, like you've done all this structural work for like nothing, and taking a inheritance parent-child structure and flattening it out is a huge pain in the ass, whereas taking a flat structure and reconverting to this parent-child structure is a lot easier. So we kind of want to do that. There's a saying that like you don't know as little about as a project as right now, so like don't build too much in the future for something you may never ever use.
All right, thanks.
Genevieve.
So what would be an instance when you would use super without arguments?
Like to send everything, or
so like, you know, you explained that it's very rare, or we would never really use empty parentheses, but I just can't think of an example when you would call on super and not give it an argument. Like in the definitionalize for super name and ID, like what if you put nothing in there? What happens?
I mean, one thing. Let's make a contrived example here, right? Let's pretend that we don't care about name or ID, and let's pretend we don't have a name or ID, right? And this therefore will not take name or ID. I could do something like Very contrived, but that is one possibility.
Okay. Got it. Thanks.
Or if there's something in your employee class that needs to, like, after you create, you want to make sure that runs for everything. Like this could, you could have some method called send welcome. And this fires off some code somewhere else that sends that employee the things, or like email, or whatever. That can be an example. Because like, when you think about it, every single employee is going to have to be, to be welcomed somehow, right? But like the details of what the creative could differ. And so that could be a thing we do, to use super without any arguments.
Got it. Okay.
Mhm.
Thank you.
Yep. But all, yeah, yes. Cool. Kyle.
The method total compensation in the employee file,
Yeah.
because it's using bonus, is that that's relying on the method in CEO, or sorry, the instance
Attribute.
variable in
Yep.
CEO?
Mhm.
Is that an example of, do you want them to be connected in that way? Or like, is employee relying on the CEO in a way that like we wouldn't want if we were designing something for ourselves?
Yeah, that's a very good point. Yeah, that is a little bit of that. Like again, this is kind of like a contrived example to kind of show like we put like strange situations here so you can see like exactly how the two are linked. But yeah, that is a great example of like how I would not really want that to link in that regard. I think I was designing this for real. I would probably make a bonus. I think it's a bigger question how we structure it. I think that if every employee has a bonus, except for like intern, I might leave this like it is. Because if the intern is the only one that doesn't have a bonus, like we can just override that there. But like when we think about the CEO and the sales manager, the CEO and sales manager both have bonuses. They're just calculated differently, right? So I think that I'd be okay. I think it's a bigger question of like how many exceptions there are. Yeah, like it's a good question. I think that like just first glance, I would probably not want bonus there, but now that I consider a little more, I'd probably leave it. And I think this goes to show that like there's not really a right way or a wrong way. It's like it's what you feel like. Yeah, what you feel is gonna save you work and understanding in the future. Right. So like for you, that thing's like, yeah, I don't want bonus in here. For me, I feel like, yeah, I could probably leave bonus in. And I'm not saying I'm right and you're right. I'm saying that we're probably both right in our own heads. Then that's okay. Cool. Excellent. Jake.
I was just thinking over your comment about how we should build structure out.
Yeah.
And that we should start with a flat structure and then move up to creating superclasses as we need them and as it makes sense.
Yeah.
And I got into modules a little bit with the event reporter. And so I guess the thought process in breaking it out at some point is like, if it's just a collection of methods, that can be a module. But we want to create a superclass when there's some attribute that like just makes life easier if it can be sorted a different way for multiple classes. Like the point of it is like to hold attributes and details versus a module.
We're gonna go module. Yeah. We're gonna go to modules more tomorrow. Let me check the calendar. Tomorrow, right? I think for me, I like when I am trying to reduce duplication code, I have my two choices are modules and inheritance. Inheritance is my choice when I want to kind of communicate that there is some sort of hierarchical structure to whoever's using it, right? I think that like for a developer coming onto a code base, you're like, okay, yeah, I get it. Everyone's an employee, there's CEOs, there's sales managers, there's interns. Like there's this hierarchical structure to the information being modeled that like is like, yes, I understand what's happening here. I can see that, like, yes, these are all kinds of employees, whereas modules can be just like a place that just repeated code can be used. Right?
Okay, I think that makes sense.
Where structure is not really like, there's not like really relationships.
So it's almost like, it's almost like a developer empathy thing where like you're trying to show people, hey, this is the structure of how this like this.
And I think that like we go back to the notes is that like inheritance is used when there is a relationship, that general specific relationship, right? In this case, the general is the employee, the specific is the CEO, the intern, the sales manager. The general is a dog, the specific is corgi, German shepherd, what have you, right? Like the inheritance is used when there is that specific relationship between two types of objects.
Okay, got it. Thanks.
Yeah, Doug?
To just tag on to that question, thinking back to our battleship project,
sure,
we had like cells and we had a board. Those would have a specific relationship. So one of those may be an inheritance of the other. But if we had
I would not inherit, because a cell is not a board.
Gotcha. Okay. But then if I had a message class that's being used in multiple places, that's more of a module.
Yes. I think that potentially, if we're looking to bring inheritance into our battleship, potentially I would have perhaps like a player superclass and like a computer player and human player subclass, right? Because that fulfills, that is a requirement. Other ones we could probably pick out, a ship class, and then a destroyer class, a battleship class, a carrier class, right? That inherit from ship. And that is potentially a thing. I think personally, I would not do that because like like ships are all the same, whatever, it's not like the classes have different abilities. They just have different sizes, right? Unless you decided to make a version of battleship where different ships could do different things, like a battleship could shoot 3 times or something. That makes no sense. But the idea is that you want more delineated things between the two. Cool. Karen?
So like inheritance is, along with some other things, just like design and thinking and setting up like how you want the structure of your program to be.
Both structural and also refactoring tool.
So like with object-oriented programming, it's kind of hard to like just talk about inheritance without talking about object-oriented programming.
Yes,
right?
Inheritance is one of the pillars of object-oriented programming.
And it's like
we're going to talk about. Well, it's one of the 4 pillars, and we're going to go, like, the thing is that we've kind of been sprinkling in the 4 pillars as we go. We've not really talked about them discreetly, but later on this module, we will talk about the 4 pillars specifically.
Okay. So it's mostly just thinking, right?
Thinking and also application. The idea here is that, like, it's kind of the big picture we want to like kind of say is that you've been using inheritance like the entire time. So the idea is that like you've been like, I'll give you an example, use enumerables, right? Enumerables run on hashes and arrays. And the idea is that like, well, enumerables are not a part of like your objects you create. They're part of like the enumerable module, which gets attached onto the array object. Right? Like the idea is that whenever we are looking for methods, we always are going up this chain.
Okay, so there's something else happening in the background that has to do with inheritance.
Yeah. Okay. A little bit. Like we're using inheritance everywhere. That's how like we use these methods that we don't have. We've never defined ourselves.
Okay, so it's also
a little bit more of that. Like we're gonna have this thing we do on the Ruby object model.
Okay, so like how it works.
Mm-hmm.
Okay, cool. Thank you.
Mm-hmm. Anything else? Cool. Yeah, super ahead of schedule. So let's take 10. Let's be back at 10:30 and we'll kick off this project.